So given that in new homes, it sounds like 200 amp service seems to be the norm here. This may have a little bit more application when we're talking about retrofits, okay? Because at 200 amps, it's a bit of a stretch to try to figure out how to use all that. All right, the electrical service impacts of heat pumps. Why should electrical impacts matter to home builders? The challenges around air source heat pumps, changing the home's electrical personality. So we're going to talk about some of the controls and mitigation strategies. We'll look at our case study home and how it performed throughout these different, with these different strategies, and then we'll talk about achieving best results. So why should electrical impacts matter to builders? Well, the HVAC selections can dramatically affect the electrical service requirements and overall project costs. The bigger the unit, generally speaking, the higher the amperage, the more your exposure to problems within the Canadian Electrical Code. And it's much worse if we have to upgrade to 200 amp, and it's much worse than that if we have to go back and upgrade a transformer. And even worse than that, if the utility has to go up, you know, let's pretend these things become ubiquitous through the industry. Now you're looking at a utility that has to upgrade your lines and substations, all that other kind of wonderful stuff. So that gets really expensive. So projects that will reduce electrical service upgrading needs are more likely to proceed. It also helps out the utility. Are we going to wind up doing a lot of this anyway as we move forward? Sure. But you know what? Let's put that off as long as we possibly can. I don't want to be the first person who has to pay, you know, tens, maybe, you know, tens of thousands of dollars to upgrade everything all the way up the line just because I wanted to have an air source heat pump or because I wanted to run a little bit of solar. So, do we have, well, I guess in new homes in Calgary, if it's all 200 amp now, you probably don't have a lot of constraints, but have we experienced constraints with projects before, residentially?
Yeah, we use load misers if you've got 100.
Yeah, so load misers, we're going to talk about some of those, splitters, that sort of thing as we move along. Okay, anybody else have some challenges? Okay. Okay, air source heat pumps and electrification challenges. We're finding homes are more electrified than they've ever been before. We've got things like heat recovery ventilators, energy recovery ventilators. We're seeing electric hot water tanks for some reason. If you're a builder and putting in electric hot water tanks, I am here to beg you, please don't.
So many.
I am begging you, please don't. Two reasons. One is greenhouse gases that we talked about earlier. Secondly is the consumer cost that we talked about earlier. An electric hot water tank costs about around $500 more a year to operate than a natural gas hot water tank, and even more than what a tankless would be. Now I understand that, you know, sometimes venting's an issue when we're talking about attached products, but my solution for that is to investigate perhaps a combi system where you still only have the one vent. But anyway, electric, and oddly enough, we're actually seeing some air source heat pump hot water tanks coming into the market. I've been quite surprised to go back to some homes and see those in the basement. Then of course we're adding air conditioning / air source heat pumps, and then we've got these wonderful things over here in the bottom left, the dreaded of all things, the EV charger. When we put all those together, a lot of people feel like they're a little underwater on it. So we have a higher continuous load demand, and 100 amp and 125 amp services, according to the Canadian Electrical Code, may need some upgrading as we add more of these electrified units to it. Now, if we have overhead lines, upgrading isn't as much of an issue. Everything's nice, it's exposed. We don't have to deal with trenching or directional drilling or anything like that. But if we're in the ground, our costs go up substantially. I think we can all agree on that. But the other side to it is, like I talked about before, is it's one thing at the subdivision level, all right? We've got 6 or 8 homes on a transformer, so we have to upgrade the lines in the ground and we have to upgrade the transformer. But if we get into a point where we're upgrading all the transformers, now we have to look at everything coming backwards from that. right? And that's where things get really expensive, because now you're talking huge amounts of infrastructure. Very expensive long-term investments in infrastructure that, oddly enough, we as ratepayers pay for. Okay, service sizing requirements for the Canadian Electrical Code Section 8. This is the residential section. Safety centered to avoid overloads in worst case scenarios. Now, I've had a few people, have a few disparaging remarks about the Canadian Electrical Code. The thing we have to keep in mind is these guys are working with a worst possible case scenario. Almost, I'm going to say almost because you can never say never, but almost never happens, right? We do not put everything on in the house all at once. It just doesn't occur normally. But the service overcurrent protection devices, like your breaker, your master breaker, you cannot just have a 100 amp master breaker and then it's going to trip once you hit 100 amps. That doesn't mean you can put 150 amps of service behind it. Okay, the code will not let you do that. Your living area will dictate your continuous base load, so the bigger your home is, the bigger your base load is. Had one fellow yesterday saying that they were running into problems with some of the additions they were putting on. And it's like, wow, that must be a hell of a size of an addition to add that much base load that you actually go over your electrical code allowance. Very impressive. Heavy loads, anything over 1,500 watts, which is basically a hairdryer, is assumed to be operating continuously. Okay? So, and the other thing which saves us at the bottom here is it includes permissible load control methods. And we heard load miser here used. We'll talk about some switches later on. So these are allowed within the code that can actually lessen the amount of upgrading that we will require. So this is really a tale of two cities if we get into it, because we have the Canadian Electrical Code that says, everything's already, always operating all at once, our worst case scenario. The utility engineering standards say differently. It's like, oh no, there's no way that everything's always operating at once. They're far more pragmatic. Okay, so that can also be a problem when we're going towards electrification, in that, we do this at development. If you're going into an existing area as a retrofit. And of course, the developer at the time, they were assuming everything was going to be 100 amp service, and now you're adding a 200 amp because of some reason you've got a net zero home that's being built, or you've got something with a huge electrical load. And all of a sudden now that transformer has to be adjusted because somebody else before you added some other electrical devices, right? You don't want to be the first person to pay for it. First person usually gets away with it. You're going to pay for a little bit of trenching and some wire. The second guy usually winds up causing a little bit of a kerfuffle as far as the transformer goes.
The developers are all dealing with it. EPCOR sends the developer like a little sheet.
Yep.
How many, what do you expect the house sizes to be in this next phase? And then they take that back and they say, okay, based on that, we need this sort of switching here.
Yep. Yeah, but again, it's, when we're looking at existing homes, and that's, again, if we're talking 200 amp in new homes, we've got a lot of headroom. I'm not too concerned about that. But if we're going into existing areas and adding air source heat pumps or any other kind of electrification, there are some strategies that we need to employ. If we want to put in air source heat pumps into existing homes, and we do, as part of that, path towards a zero carbon economy, we want to get into those air source heat pumps. There are some constrictions, right? And to pay, I remember doing one home. We did a net zero community down here. First home that we actually did, we had to trench back to the transformer to bring the current up to 200 because there was no such thing as load misers at the time, and that was a $7,000 bill, and this is 15 years ago. I can only imagine what it is today. I don't know if anybody got an idea? No, this was in way down south. Cranston.
Oh, yes.
Yeah. So.
The Zen project?
Yeah, it was in some of Brookfield stuff. I used to work for Landmark, so we built about 20 or 30 homes in an area that were all net zero or near net zero. Lots of trenching in that area because we only had 100 amps to work with. And no such thing as a load miser. So none of these strategies existed. It was very expensive. Okay.
Is that like a huge consideration now with these infill properties that there's
100%.
Yeah, hugely, right?
100%.
4-row townhouses where one house was before, and building them to net zero
Yeah.
standards. So
Yeah. Well, you're building them to net zero standards, or if you're electrifying them, and God forbid if you're putting, and a lot of these infill areas, you still have overhead lines,
Yeah.
which make it a lot easier. Okay. But if you're doing any kind of, future infill where, we've got underground services and we're putting a fourplex where a single family home used to be, whoo, we got some issues.
I've seen it a couple of ways. The cheapest I've seen was one customer had like the wire. It was only like $1,600.
Yeah.
Another, they upgraded to the transformer was fairly close, and they went to 400 amp, and it was like 40 grand.
So they went to 400 amp.
Yep.
Were they doing like
All of that.
Bitcoin mining or something, or?
No, they had 2 furnaces. And, yeah, they wanted
Ooh.
to, yeah.
Little hydroponics in the
Yeah,
basement,
like-
perhaps.
Yeah.
Just
600, yes, it's 6,000 square foot.
yeah.
That, eh?
a 400 amp service. That's a monster.
Yeah, but it was 200 amp.
Yeah,
Yeah.
Circuits.
yeah. Anyway, when we get into this, again, we talked about how overcurrent protection devices do not limit or justify the service size. So you can only put 100 amps on a 100 amp service. You can only put 200 amps on a 200 amp service. If you've got your Bitcoin mining operation or your hydroponics going in the basement, you may need to tap your neighbor. Oh no, that's not it. You may need to upgrade your service.
We had 2, just so you know, did 60 amps on each of the furnaces, right? It's right there. It was 100.
Yeah, so those are some big furnaces.
Yeah.
Yeah. Okay, so living area dictates our continuous basic load. So the first thing we have to do is figure out how much living area we have. So in this home here, we have about 262 square meters all together. So we have 5,000 watts for the first 90 square meters and 1,000 watts for every 90 or portion thereof afterwards. Okay, so the effective base load for this home is 7,000 watts, or pretty much 29 and a bit amps. So it's actually not that bad. We still have a little bit of headroom over and above our base loads. Now to that base load, we have to add a few other things. Space heating, air conditioning, domestic hot water, electric range, electric dryer, EV charging, and if we're doing hot tub, sauna, that sort of thing.
Secondary speed involved.
Well, we're not even going there because now you're changing occupant loads as well. So your base load will change, right? So now you have basically 2 dwellings, which really throw things off. So now you have twice as much heating, you have twice as much air conditioning, you have twice as much of everything. It's double the fun. So anyway, even though permissible deratings apply, the space heating and stuff can quickly eat up this margin. Where did we go? There we go. So I guess the question that they had for this at this point was, have we had any customers that are planning electrification in addition? Are they talking about EV chargers, pools? So from the builders, have we seen EV chargers be a thing?
They don't tell us till they want to move in.
Oh, okay. Yeah, this is a great house, but as a deficiency,
You need to make a bear.
I am missing my EV charger.
And a hot tub too.
Oh, and the hot tub. Okay, great. Yeah.
That's so common in home warranty calls.
Is it?
Oh, all the time.
Every
that's
so
the same.
so as far as home warranty goes, what are they upset about?
Well, they buy their home,
Yeah.
and it's already at 90% of the 100 amp service,
Oh,
and all of a sudden they add EV, and they're at a hot tub, and then blowing breakers, and the builder says, "But we're at permit. We're where
Yeah.
we need to get the permit."
yeah.
And the home homeowner says, yeah, but we told you we were thinking about it. The builder says, but you didn't pay for it.
Yeah, exactly.
So when you start adding, like, I think heat pumps are an amazing thing, and they're gonna come a long way and change it, but the builders need to change the attitude on
Yeah.
permitting too, because a lot of times, there's no room left in a 100 amp service. There's the 5% minimum safety factor that may still be there,
Yep.
but the reality is once you put a hot tub in or your
Yeah.
EV charger, you're done.
And that used to be the case. So what we're going to share with you today are some strategies that can circumvent that. Okay? So when homeowners show up, and I mean, like I said, I've been in this business 40 years. We all know what they're like. It's, why did you not anticipate all of my needs for the next 20 years? I paid you good money. What's the matter with you? It's absolutely ridiculous. But, there are some strategies that can actually help you. So when you are going out there, you can say, listen, have you considered this, that, or the other thing? Let's talk to a master electrician. Let's talk to an electrical engineer and figure this all out. It's really not that difficult once we get into here. But this has been in the past. Again, like we go back to our division in Cranston. We wound up back trenching an awful lot. We changed out transformers. We did all kinds of crazy stuff just to get these near net zero homes or net zero homes operating, because the electrical thing just didn't work. What we had so much solar generation, and even though solar generation isn't current being used, you still have to allow for it on the exit. So it doesn't help you any. It actually hinders. So again, going back to our case study home, we have 2,685 total square feet, including the basement. We've got our heating and cooling loads. So we've very carefully sized our air source heat pump equipment. And then we're going to start talking about adding some load limiting or selection devices. And this is what we were hearing about before, the load misers and splitters. Prioritized load enabling or shedding, which is smart panels. Got some good information from an electrician on that yesterday, which I appreciated because there was something I didn't know. I was this many years old when I learned it. And then we'll give a sneak peek at what could happen. It's not ready in most places in Alberta yet, but as we found out yesterday, MedHat has it. And we'll talk about that demonstrated load that is kind of the savior for anything existing. Okay, here we have a 100 amp service in our home. Now what we've added is we've got our base loads that were calculated, that 29.2. And then we've added to that in our electric range, electric dryer, and an air conditioner just for giggles. And we are still well within our allowed amperage. Okay? So we're doing fine. Now, one of the things that we have, and I think you're right, this belongs in a little bit later down the road. These are some of the rules around electrical usage. So an EV charger load can be neglected if the load's in the service calculation, if it is switched or it's on a real-time monitoring device. So that's your load miser, smart switch. If multiple loads are connected such that only one may operate at once, only the largest load need to be considered. So if you've got, with some of these load misers, if you've got 3 or 4 things on their monitoring device, and then you've said, yeah, it taps out at 40 amps, which is pretty much your type 2 EV charger. If it hits 41 amps, somebody tries to use the EV charger with your electric dryer, everything shuts down. You still only have to put on your application the largest load, which would be your EV charger. So the splitting and sharing can actually bring down your requirement, okay? And then service sizing calculations for electrical retrofits can be based on historical load measurements, and that's called the demonstrated load method. We don't have that available here in Calgary or pretty much anywhere else in Alberta except Medicine Hat that we know of, but it is something that I think ultimately will come. So we have carefully selected our air source heat pump equipment, and it says here this is the direct responsibility of the HVAC guys. We extended the cold temp operating range with a cold climate heat pump. So the cold climate air source heat pump goes down to a lower temperature, and that reduces our dependence on what might be an electrical backup system. Okay, and then we can also do the same thing with natural gas, because of course there's no electrical loads with the natural gas unit, because it's either on or your air source heat pump is on. So you only use the largest electrical source there. So smart load switch. So what this does is this will monitor a number of devices or a number of circuits, and only once it hits the load that we've set it is. In this particular case, we've got it hooked up to an EV charger. It might be hooked up to a dryer someplace else. It might be hooked up to your Bitcoin mining system. I have no idea. But only one of these things can run at one time. So don't run your Bitcoin when you're trying to charge your vehicle. So the EV charger can only operate when charging will not exceed the service rating. And this actually makes sense. And it'll make more sense as we move along into smart metering and things like that, time of use, because you probably want to charge your car when electricity is cheaper. And it's cheap between, 1 a.m. and 4 a.m. in the morning, right? Nobody's using that much, so it's relatively inexpensive at that point. You don't want to charge your car when you come home from work at 5 o'clock, because that's when electricity is most expensive. And then the other one is just a straight splitter. I call it an A-B switch. Only A or B can work.
Are those allowed?
They are allowed.
I've seen a few of them. I didn't know if they were allowed or not. Customers buy them online.
Yeah, they have to be ULC CSA certified.
Like I said, they buy them online. And
that's where we get into difficulty, as we found yesterday.
I have one in my home that was.
And they're allowed?
Yep, it's approved
I've
by
seen
the
a few
electrician
of
and
them.
by the city.
Customers showed me that, but they buy them online. I don't know if they're allowed.
So I use mine seasonally between an air conditioner and an electric garage heater. So
Looks like
it just
it works.
prevents either one running in the other season.
Plug in and one plug in. Good to go.
Yep. Yeah. As long as they have a ULC rating.
Cheap.
They're like pretty cheap.
Yeah, I didn't know this when we were doing this, but yeah, Joe's got actually all of these control devices in his house. He decided to sample all of this before we did it. So if you want to talk about living with it, and that's really what it becomes in a lot of cases, because we kind of live in a society right now where people say, I can do everything all at once. If we want to keep things relatively cost effective and we don't want to pay for the 200 amp service upgrade, we may have to learn to live within certain constraints.
It's just that insurance-wise, if that say cause fire and it's not UL or like you said, CSA, insurance company would look at us.
Well, theoretically, this would show up on the permit and on the inspection, right? So an inspector would look at this and would be looking for the ULC or CSA rating on it. If it wasn't there, it would fail the inspection, and that's kind of your out. We've had this inspected. It's actually permitted. It's when you don't do the permit and you're try to get away with some stuff that you're going to wind up into trouble.
I did show. I took a photo of one. I showed a customer that, and he wanted us to put it in. We got an electrician in. He wasn't going to touch it. He put in the loadomizer, which is.
Yep. Yep.
But it was more expensive, obviously.
Yeah. But either one works, and this is what's coming down the pipe. I had no idea until yesterday why. The problem is these have a UL listing in the States. They do not have a ULC listing here.
Yeah, C.
Which is why we don't. The C is important. When I was doing R&D, there used to be an agreement between UL and ULC that they would accept each other's labels. Apparently that does not cover anymore. So we're waiting for this to get a CSA/ULC rating. But these things are kind of the bomb diggity. They will allow you to program and do a lot of things, and they're probably way smarter than I am.
These are. There's a few companies that are doing that. That's nice.
Yeah. It might be a Siemens. Yeah. I'm not sure whose that is. That they didn't put a brand on there.
type of thing.
Yeah.
All that.
Yeah. So the nice thing about these things too is, they can also tell you, what circuits and things like that are operating. They can give you some good data logging. There's a lot of benefits to these sorts of things. But they're not widely endorsed by safety authorities, but in Canada you can't use them because they're not ULC rated. But it's coming. So what we're going to do is we're going to throw our case study home and we're going to oversize the air source heat pump just for giggles. So again, we've got our effective base load at 29.2 and we've added the air source heat pump with a 4-ton, which uses 22.1 amps. So we're still within, but it's not going to give us a whole lot of room for anything further. Okay. So again, sizing can actually have a little bit of an effect on there, and it gets even worse if we try to add supplementary heat. Like if we go back, this is based on a natural gas, and we make it. As soon as we add electric back up to it, we are outside of our ability to do this without any mitigating strategies. Okay, here's our all-electric solution. So we've got the EV charger, the air source heat pump 3-ton, supplementary heat, and apparently it looks like we've switched the EV charger with a domestic hot water tank. So only one of, or we've switched it with something else, not the hot water tank, but we switched it with something else, splitting it with the dryer. Okay, there we go. We split it with the dryer. So there's no service upgrade. We are just under, and we've actually added the air source heat pump and EV charger, and we have electric supplementary heat. So if we take that electric out, we've got even more headroom. So if we've got natural gas or something like that. So with these load misers and these splitters, there's a real opportunity for us, even in the retrofit sector, to keep this under 100 amp for our clients.
Just a comment about that electric heat, probably not right, that number. Because we're seeing, you're looking at that 20 amp, I would be surprised. That's only about 5,000.
Yes, we got a 5,000 watt supplementary heat system. Yeah, which 20 amps makes sense.
That'd be right?
For the sizing, yeah, because keep in mind, when we're running this supplementary heating system, that 5,000 watts is running in addition to the air source heat pump. They run at the same time. So you're getting heat from both. Yeah.
Is that for 1820? It's a 2,600 square foot home.
No. Well, above grade, 18.
So 18.
Yeah. So you got 40,000 BTUs as your peak load. Well, 38,000. So the last strategy that we can use once we get into smart metering and things like that is we can use historical load measurements. So we can actually look at our history of what's actually been used, and we can use that to predict what the future is going to be. So they have to be, they can be used for retrofit projects. Unfortunately, they're no damn good for new homes because we don't have that data. But they must be completed by a qualified professional, usually a master electrician or an electrical engineer. And the data is very specific. It has to have hourly data, and it has to be over a 12-month or more period. So I think, yeah, so there we got availability in Alberta. ATCO has a few smart meters going right now. We found out yesterday that the City of Medicine Hat is all smart metered. They do not do time of use, but this data is absolutely available. So there are places that are starting to go that route. And this will really help us when it comes to doing the retrofits, which oddly enough, if I can stand on my soapbox for a minute, that is where the real opportunity for greenhouse gas reduction lies, not in the new stuff. If we've got older homes and electrification and adding heat pumps and adding insulation, that is where we make the biggest gains. So we also have to find ways to make it happen so that they're not paying $6,000 or $7,000 in additional upgrades to their electrical service. So it's not currently permitted in Alberta, but used widely in BC and Ontario. New installation smart meters raises the potential for use in the near future. I don't know when that's coming in. Like I said, we had one utility in Medicine Hat, and he said, yeah, no, we already got it. So there was that one. I don't think we have any utility people here, do we? no.
Medicine Hat is its own kind of
Yeah,
microgrid.
oh yeah,
to
no,
begin with,
they're a
so
microcosm of themselves.
They have a lot of
Yep.
flexibility in the things that they can implement.
Yeah. But smart metering, you know, and time of use billing it's coming. Because quite honestly, it's a more creative way for the utilities to separate you from your money.
What is this smart meter? Is that the reverse meter?
Nope, no, smart meter, what it does, again, like I mentioned earlier, what a smart meter does is it will charge you depending on the time of day that you're using the electricity. Electricity in Alberta is, the cost of electricity at generation changes every single hour, depending on the usage. And it can range anywhere from almost free to over $1 a kilowatt hour at peak times. So it's an interesting thing. When you get into that, and one of the things we talked about in one of the first slides was in the province of Quebec, you know, shaving peak usage is a challenge in Quebec, right? That is one strategy to shave peak usage. If, you know, pretty much a lot of people go home at between 5 and 6, and they start dinner, and that's a high usage of electricity. Well, if you're paying a lot of money to do that, perhaps you might want to entertain what my parents used to call dining with the elite, and have dinner, you know, closer to 7 or 8 o'clock at night, and save the money on the electricity, and that shaves that peak, flattens it out a little bit.
The smart meter help you to do that? Somehow?
Yep. Yes, because you pay more for peak usage, you pay less for off-peak usage. People, the people's behavior, because they want to save money, they will move to a less peak usage. Okay? So when we're doing this, the loads to be added are augmented load may be calculated by adding the sum of the additional loads to the demand load as measured over the 12 months, so that's the historical usage. The maximum demand load may be obtained by using that number times 125%. So even there, we're demonstrating that we're throwing in a safety factor. And then the new load, your hot tub, electric vehicle charger, etc., can then be added to the utility supplied load to calculate the new demand. So let's have a look at that. And we're going to make a few assumptions here. So in this presentation, when it was given in British Columbia, the fellow that did this presentation did this live. He actually went on to his own home and pulled this data off his BC Hydro account. Okay, so when we look at this, his highest peak load is 26.7 amps. That's his highest load in his house. That's a long way from the 100 amps that they would probably assume that he's using, right? So if we throw that into our calculations, we have the maximum historical data, so we've added 25%. So we have 33.4 amps. So we've added 25% to that 26.7. And then we've added our air source heat pump and our supplementary electric heat system, and we are still within our allowable load. So while this is not the norm yet in Alberta, I think at some point in time, just because it's a great way for the utilities to manage their peak usage, I think we will see this. And this actually gets the happy face smile of approval from Natural Resources Canada. Okay, so key takeaways. Please be mindful of how HVAC electrification impacts. All right, careful selection is important. We want to make sure that we get the right size of product in there so that we're not using that extra 10 amps or whatever that could possibly cause our client to have to trench something. Classic service sizing assumes concurrent loads. So let's talk to our electrical trades early in the project and mitigate some of these. If we know we're going to be over, let's talk to the electricians about getting some load misers in and things like that, and save these people the money. The switch, even if you're just doing one switch, like how much was it?
Under $500.
So it was under $500 for the switch installed. Okay, so under $500 installed at a retail level. So you know, my math might be bad, but I think that's a savings over the $6,000 or $8,000 you'd spend in trenching. And the Canadian Electrical Code Section 8 provides methods that can soften the impacts. That's what we talked about. And hybrid heating solutions are more easily managed under the CEC because we don't have to allow for them being running at the same time.